Good morning, one and all. So today is the second session for signal flow graph. So this is lecture number 12. Lecture number 14th on 12th of May. What we are going to do today is we are going to do some two very typical complex numerical, and we are going to see the fundamental of how the delta k actually is found out in numerator. So what is found is most of the students they write denominator equation properly, but denominator is nothing but the determinant. But how to find numerator equation, that we will learn properly by two examples now. And two examples are similar, and based on these two examples I have formed a third assignment which you have to solve. So all these three numericals are in the same line, they look almost similar, so I have increased the difficulty level step by step. So first numerical is the easiest, second numerical is little difficult than that, and third numerical, which is given as a homework so that you have to submit by tomorrow 10 a.m. in the morning, that is actually a little more difficult numerical, but not very difficult. Don't worry, you can solve it if you follow the first two numericals properly. So there's a numerical. First, we are going to see in this case, whatever we are finding is RS is the input and CS is the output, and there are two paths. Okay, so these two are parallel paths. So G5, G6, G7 multiplied with G1 and G8. So G1, G5, G6, G7, G8. This is the first forward path, and G1, G2, G3, G4, and G8. This is the second forward path. So you are finding here number of forward paths k is equal to 2. So T1, so this path is named as T1. So first forward path T1 is equal to G1, G5, G6, G7 and G8. So it is named as the first forward path, and it is connected with loop L1. Okay, so there are two loops in this circuit. So first loop is L1 minus H6G6. It's written here. So L1 is minus J6H6, and it is connected with loop T1. So previously we had called it T. We are calling it T. That does not matter. So G1, G5, G6, G7, G8. This is the first forward path. Second forward path is below G1, G2, G3, G4, G8. So this is we are calling as T2. So T2 is equal to G1, G2, G3, G4, G8. And this second forward path, that is T2, it is connected with loop L2. So you are finding that loop L2 is equal to minus H3G3. Now this thing is very clear, so it's a very easy kind of a numerical, nothing very difficult in this. So what we are finding is these two loops. So the for top loop L1 is having two nodes, bottom loop L2 is also having two nodes, and all the nodes in both the loops are separate. That means these two loops are non-touching loops. So there is only one single pair of non-touching loop in the system. So number of two non-touching loops or pair of non-touching loop is equal to 1, or combination of two non-touching loop is equal to 1. That means there is only one pair of non-touching loops. So multiply their gain. So if you are multiplying their gain, it is L1 into L2. So all these negatives will become positive. So it will be G3 G6, that is this G3 G6 multiplied by H3 H6. So this term will come in the denominator, and combination of three non-touching loops, combination of four non-touching loops, all these things are not there because this is a comparatively easy numerical. So from all this, whatever is shown here, that is forward path gain, it is not actually required in the determinant delta, but L1, L2 and L1, L2. So these are the three things which will come at the denominator. So whatever is the denominator of the transfer function is also called as the determinant. So that will be delta is equal to 1 minus, so this is individual loop gain, so this is L1 gain plus L2 gain plus multiplication of the pair of non-touching loops. So this is L1, L2. So if you substitute all the values, what we are going to get is delta is equal to 1 minus H6G6. So this top one is minus H3G, this is minus H3G3, and finally plus, that is the pair non-loops there. Minus 6G6 and minus H3G3, so you multiply that. So what is the final delta? So this is the this is 0 is called as characteristic equation of the system. So what is that? It is already found 1 plus H6G plus 3G plus H6H3G3. So you can see that everything is positive in denominator. Why? Because there are only two feedbacks and the both feedbacks are negative feedback. How we will know? We will know by doing this. So this is also minus H6 and coming back. This is also minus H6 and coming back. Okay, so both the feedbacks are negative feedbacks, and there are only one pair of non-touching loop. So this is the single loop gain, this is again the single loop gain, and this is the multiplication of two non-touching single loop gain. So there are only four terms at the denominator. So this numerical is actually very easy. Now we are going to see what we are finding next. So we have seen that there are two paths T1 and T2, two forward path, and there are two loop gains L1 and L2, and we are finding that this forward path T1 is touching L1 and forward path T1 is not touching L2. So while calculating delta 1, that is while finding the numerator for T1, this term 1 plus L2, it will come in case of the numerator. Samely, forward part T2 is touching L2 and forward part T2 is not touching L1. So this L1 loop is not touching for T2. Hence, while you are putting this gain, that is T2 gain in the numerator, there will be multiplied one term with this T2 gain, that will be 1 plus L1. So how to do that in a mathematical fashion, that we are going to see now. So denominator equation is equal to delta is equal to 1 minus L1 plus L2 plus L1 L2. We have seen this also we have derived in the previous page. Now we are directly finding what is transfer function. So CS by D, here I am showing T1, so you can write this T1 and T2, or P1 and P2 does not matter as long as you substitute the values correctly. So as I have written T1 here, here also you can make T1 delta 1 plus T2 delta 2. Doesn't matter. Only delta 1 and delta 2 value you should know how to calculate, and that is where the students are making biggest mistake. So next job is to find out delta A. So delta 1 and delta 2. Why there are two delta? Because there are two forward paths in this numerical. That's why there will be two delta. Sometimes what we find is one forward path is touching all the loops, so in that case all the delta will be equal to 1. But in this case we are finding that T1 is not touching loop L2. That means in P delta 1 there will come a bearing of L2, and we are finding that this L2 is for the path T2. So T2 path is not touching this L1. That means in this delta 2 there will come a term of L1. So how exactly to find it? We have already seen in the previous numerical. In this numerical also we will see. So what is the value of P1? P1 is same as T1, that is G1, G5, G6, G7, G8. So that is the P1 value. Delta value already we have calculated. What is P2 value? That is G1, G2, G3, G4, G8. So P1, P2 delta. Generally, we find students find it very correctly, no problem. So P1 is G1, G5, G6, G7, G8. P2 is G1, G2, G3, G4, G8. Delta is 1 plus L1, L2 plus L1 plus L2. So all these things is found. The only problem is how to find delta 1. That is also easy. Okay, so first you have to see you are finding delta 1 for which forward path. So delta 1 we are finding for forward path T1, and T1 is touching L1. That means while finding delta 1, you write the equation of delta, same equation of delta. That is same equation of delta. That is delta 1 is equal to delta. Whatever is the delta value we have found in the previous case for denominator, the same value. And as T1 is touching L1, that means in this delta equation, you make all the L1 is equal to 0. So I'll repeat the process. We are finding delta 1 because delta 1 is connected to T1 or P1. Now we are finding that this T1 path is touching L1. So how can I find delta 1? So while finding delta 1, write the same equation of delta. And as T1 is touching L1, in the equation of delta, substitute all the L1 as 0. So in that case, what you are finding is hence delta 1 is equal to delta. So in this equation, main equation of determinant, for all L1 values is equal to 0. That means it will be 1 minus, it was L1 plus L2. So in case of L1 substitute use 0, and in case of L2 substitute L2 plus L1 into L2. So L1 make it 0 and L2 leave as it is. So what you find is delta 1 is equal to 1 minus L2. And what is L2 value? This is minus G3H3. That means what will be this delta 1 value? 1 minus of minus G3H3, that means 1 plus G3H3. So this is the simplest trick, and this was the only thing which was pending to be told. And for all coming numericals, further numericals, the same trick you have to apply. So first you have to see how many forward paths are there. If there are 6 forward paths, then you have to find delta k for 6 times, and you have to find which forward path is touching which loops. So if a forward path is touching one loop in the delta equation, so delta equation already you have to find first from the initial declaration. So from step 1 2 3 4, step 5 you have to find initial delta, which is the determinant, and in the step 6 you are finding what is called as delta k. So step 6 is most important, and that is where the students are making most of the mistakes, and this is actually step 6. There is nothing difficult. You have to find delta 1. So you have to find delta 1 for T1 forward path. So whichever loops the forward part is touching, all those loops have to be made equal to 0. Okay, so in this case this T1 is touching the forward sorry, the loop L1. Hence delta 1 will be 1 minus 0 plus L2 plus 0 into L2, because I am finding delta 1, and as T1 is touching L1, then delta 1 will be 1 minus L2. That means all the L1 I have made equal to 0. So this will be 1 minus L2, and L2 is minus G3H3. Hence delta 1 is equal to 1 plus G3H3. Same rule applies for L2 also. Okay, so now we are trying to find what is delta 2. So what is the value of P2? P2 is the below a forward path, that is G1, G2, G3, G4, G8. Okay, so this P2 or T2, whatever you call it, this is G1, G2, G3, G4 and G8. Now I am trying to find what is the value of delta 2. So delta 2 is delta for all L2 values is equal to 0. Why L2 value? Because this below forward path, that is T2 or P2, whatever you call, that is actually touching L2. So whenever there is a touch, at that time we have to substitute that loop value is equal to 0. So how can I find delta 2 from this delta? In this delta, if we substitute all the L2 is equal to 0. So that is what we are doing. All the L2 value we are making 0. That means it is delta 2 is 1 minus delta 1 plus 0 plus delta 1 into 0. So the second term or third term becomes totally 0, and 1 minus L1, this remains. And in this you can find that L1 is equal to minus H6 G6. So this will be 1 plus G6 H6. So now in this transfer function, all the things are known to us. So what is this P1? So P1 is actually from T1. It is G1, G5, G6, G7, G8. What is delta 1? So delta 1 you have found out, that is when path T1 is touching L1. So in delta, all the L1 have to be made equal to 0, because I have taken delta 1 as 1 plus G3H3. So what will be P1 delta 1? It will be this forward path gain G1, G5, G6, G7, G8 multiplied by 1 plus G3H3. Same way, what is P2? P2 is G1, G2, G3, G4, G8 multiplied with delta 2. Delta 2 we have found as G6, H6. So this is the numerator. And what is denominator? We have already found. It is easy. 1 plus G6, H6 plus G3, H3 plus G6, H6, G3, H3. So all these things, if you put together, just see what all we have found. So only difference mistake I have made here in this case is T1 and P1 I am saying taking to be similar. So in the exam, if you want, you can write T1 as P1, or this P1 you can write as T1 also. That does not matter. Only clearly you have to mention that T1 or P1 you are taking as a forward path. So this transfer function is very short. Okay, just you look at the numerical and you can write this in one statement, and you can start describing after that. So what is the denominator? Denominator is very easy. There are two loops and all the negative feedbacks are there. So that's why everything is positive in the denominator. So 1 plus H6G6 plus H3G3 plus H6H3G3G6. So this denominator writing is very easy. Then numerator is having two forward paths, G1, G5, G6, G7, G8. That is the first forward path, and it is touched by L1. So the other part, 1 plus G3H3 will come and get multiplied with the path P1. Samely for P2, that is G1, G2, G3, G4, G8, it will be taken as P2, and whichever path it is not touching, okay, that path loop gain will get added with 1. Okay, so it will be 1 plus G6H6 because this first loop L1 is not touched by the bottom forward path. Okay, so this is the whole transfer function, and there are four terms in the numerator. If you just multiply all this, there are four terms in numerator and there are four terms in the denominator. So this is a medium level difficulty, but actually this is kind of an easy numerical. Whenever you will be solving a lot of big numericals, this numerical falls in the category of easy numerical. But this is very much interesting because here we can find out the fundamental of delta k very clearly. And this is a symmetric kind of a circuit with respect to the horizontal axis. So it is with respect to the central axis. This is a kind of a perfectly symmetrical axis. That means what happens with loop 1, the same thing happens with loop 2. What happens with path p1, same thing happens with the path p2, and all those things happens. But denominator is not symmetrical because denominator there are three terms, three type of terms. One is a constant term, one is single loop gain, and another one is a pair of loop gains. So this is a very simple numerical. Next, what I'll be doing is I'll increase the difficulty level. I will connect this G2 with G6. So these two nodes I will connect and I will give a gain name. Okay, so next circuit is not next system is same with two changes. The names might change, G5, G6, and all those things might change. Okay, there will be some name, but sequence might change. And second thing is this will be connected. So this node will be connected with this node, and this node will be connected to this node. And that crossing point is not touching each other. It's like a jumper in the circuit. Okay, so it's like this one, maybe it is called G7 and G8. So we are going to connect this to diagonals. Okay, so one is having a gain of G7, another is going to will be called as a G8, and they are like this, they are not touching each other. So that will be our next numerical. We are going to see here. I think the system is visible. So names I have changed. So here it was G1, G5, G6, G7, G8. So names have changed, so there is no G1 here, so G1 is coming here. Okay, but the circuit system is same, only the names have changed. So there are two changes, only the names I have changed. That is one thing. Second thing is this diagonal I have connected and given it a name of G7, and this diagonal I have connected and given as a name of G8. What main thing you will find is in the previous system there was only two forward paths. As you have connected this, you will be finding the number of forward paths will be 6. Okay, so there will be 6 forward paths now. Okay, and I'll show you how it happens. Okay, so and very important thing, this point is not connected. So G7 and G8, they are not connected at this point. They are like this jumper. Okay, one wire is going on the top of other. So if you're looking from the top, it might look that they are connected, but they are not. Okay, so this is the first thing, G7 and G8 paths are not connected. That means when they are crossing. So this is not a contact point. Okay, this is a jumper that you have to assume. So wherever contact point is there, it is given by a node. Okay, wherever contact point is there, it is given by a node. So as there is no node shown here, this is like a jumper. So they are like jumper wires. So first thing we are supposed to find out, so you have to write accordingly. Step 1. Okay, so this is the way you write in the exam as well. Step 1, there are 6 forward paths. Now this is a challenge. I'm asking you, your observation power you have to make a lot better. So what is P1? So P1 is, it's very easy, G1, G2, G3. You can find here this P1 is G1, G2, G3. And this circuit is also symmetric with respect to the RC axis or horizontal axis. So whatever happens in the numerator, that will be even terms. So P1 is equal to G1, G2, G3. That is the first thing. What is P2? G4, G5, G6. So P2 is G4, G5, G6. Third term P3. Oh, now here is coming the complexity. P3 is G1, G8, G6. So you are coming from here R, then G1, then G8, and then G6, and then outside. Okay. So third forward path P3 is 1 into G1 into G8 into G6. So third is P3 is equal to G1, G8, G6. In the same way, fourth will be come here G4, G7, and G3. So P4 is G4, G7, and G3. So up till now it was kind of easy. Now too much of complexity has been added. Now you have to be really observant to understand what is P5 and what is P6. And a very important thing we will see that here the feedback is taken into the forward path. So that is a very new thing you are finding and only in this numerical. So let us see what is the fifth forward path. So we are coming from here First it is going up G1, and then it is coming below G8, and then here this minus H2, okay, and then it is G7, and it is G3. Okay, so very important thing, first it is 1, then G1, and then G8, and then minus H2. So after G8, after this node it is coming below minus H2, and then G7, and then G3. So this thing P5 is equal to G1, G8, and then this feedback path minus H2, and then this G7 and this G3, and it is coming to the C, that is the output. Okay, very important thing, again I'm telling you, this point is not touching. Okay, so in loop or in forward path, one very important thing is there, in forward path, not in loop, in forward path, one very important thing is it should not touch one point more than once. Okay, so I'm telling you again, forward path, how do you define forward path? A forward path does not touch one point twice. That means, hence I'm telling you this point, okay, had it been connected, you could not say that this is coming back again, it is coming here, because while crossing it, it is touching this point once. Okay, so if this point is connected in some numerical, if this point is connected, then you cannot say this is coming here and again coming here and then touching. No, in that case it does not happen, because while coming below it is touching this point again, and when again going above it is touching this point again. So in that case, that forward path we cannot consider. Okay, something else we have to do in that case. Fine. So P5, again you see P5 is 1, G1, G8 minus H2. Okay, then there is coming G7 and G3, and this is going outside. What is P6? That is the last forward path. Last forward path is you have to come below. So first is G4, then G7. Okay, so first you have to come below G4, then G7, and then minus H1 is coming into picture, and then G8, and then G6, and right side. So this is given here P6. What is that? First is G4, then there is G7, and there is minus H1, and then there is coming G8, and then G6, and coming outside. So these are the 6 forward paths. So P1 is G1, G2, G3, very simple. P2 is G4, G5, G6, very simple. P3 is G1, G8, G6, this is a crisscross. And P4 is G4, G8, and G7 and G3. This is also crisscross. And most complex is P5 and P6. So what is P5? P5 is G1, G8, minus H2, G7, and G3. And what is P6? It is G4, G7, minus H1, G8, and G6. So these are the 6 forward paths. That means you have to find delta for 6 cases. So in that case, thing becomes a little difficult. But this numerical looks difficult, but it is actually not very difficult. We will show you. Next is find how many loops are there. So one loop is very simple. So first loop is L1 minus G2H1. You can find here. L1 is minus G2H1. Second loop is also very visible, easily visible. That is minus G5 into H2. Okay, this loop is also very visible. Third loop, you have to have very good observation. Okay, so that is loop created by G2, G8, G5, and G7. Okay, no, not that. Okay, loop created by minus H1, G8, minus H2, and G7. So just see this 8 thing. Okay, so if you are practicing yourself, you will find that this 8, whatever is the 8, bigger 8. Okay, so if you start from here, let's start from here. So what is the loop? What is the difference between loop and forward path? So forward path does not touch the same point twice. Loop starts from one point and come back to that point. Okay, so start from here. First you are going minus H1, then you are going G8, and then you are going minus H2, and then you are coming to G7. So again I am telling you the L3 loop, that is minus H1, then G8, and then minus H2, and then G7. Okay, so if you are seeing all this, this minus minus will become positive, so it will become H1, H2, G7, G8. And this looks like kind of a double negative feedback. So double negative feedback means positive feedback. That means this term will create a negative in the denominator. So again I'm telling you, this is the third, there is a third loop. So L1 and L2 I have shown, L3 I have not shown intentionally because I wanted to tell it very clearly to you. Generally you cannot see this. That's why practice is very much important, and you have to observe We have to find this loop. So whenever there is a feedback path, be careful, try to find out a loop related to it. More than once may be there. Okay, so loops can overlap. So L3 is overlapping with both L1 and L2. That is possible. Okay, so what is the third loop? This is minus H1, then you go to G8, then minus H2 and G7. So this is the third loop. And how many non-touching loops are there? So only this L1 and L2, they are not touching loops. Okay, so three loops are there, but this third loop L3 is touching both L1 and L2. So there is only one combination of non-touching loops. And what is the gain multiplication of that? So H1, H2 and G2, G5. So it is given here L1 multiplied by L2 is, you just multiply these two, L1 and L2. So you're finding that multiplication of non-touching loops, it will be H1, H2 and G2, G5. So that is this loop at the top and this loop at the bottom. And three non-touching loops are not there. And delta is also very easy. So what is delta? Delta we have found here. So 1 minus individual loops. So how many individual loops are there? There are three individual loops. So all these three things you have to write here. That means it will become 1 plus G2H1 plus G5H2 minus, because here both the minus are getting multiplied and it will become positive. So 1 minus of minus. That means it will become, denominator will becoming 1 plus G2H1 plus G5H2 minus H1H2 G8 G7. Okay, this is the thing, and plus multiplication of these two. So plus G2 H1 G5 H2. So there will be 1 2 3 4 5. There will be 5 terms. So 3 for individual loops. The things are here. Only their sign will change and they will get added with 1 plus L1 L2. So what is L1 L2? G2 H1 G5 H2. That means in the denominator there will be only one term which will be negative. That is this term. So it will be minus H1, H2, G8, G7 at the denominator. All other terms will be positive. So denominator is not a problem. So who is a problem? Problem is the numerator. Because numerator there are 6 different forward paths, and each forward path will be having a delta. Okay, now let us find out what are the paths and which are the delta. So how to find it? So the determinant of the graph is denominator delta, that is equal to 1 minus individual loops plus multiplication of two loops which are non-touching, that is this L1 and L2. L3 I have not shown intentionally. Step 6, so here all the forward paths are there. So now we have to see the paths and accordingly we have to calculate the delta k. So delta k is formed by eliminating loop gains that touch kth forward path from delta. That means let us find out. So P1 is given as G1, G2, G3. So P1 is given as G1, G2, G3, and this is touching L1. Okay, so how can you find delta 1? So P1 is the forward path, first one. So how can you find the delta for this? So what is delta 1? So delta 1 will be, as this forward path is touching the loop L1, that means in the equation of delta, substitute all the L1 is equal to 0. That is the way you can find out what is called as the delta k or delta 1. And at the same time you are finding that this forward path, that is G1, G2, G3, it is touching that 8 also. So this 8 L3. Okay, so this forward path G1, G2, G3, it is touching L1. So L1 is only this loop, and this forward path is touching the L3 also. That means in this equation of delta, you substitute L1 is equal to 0, L3 is equal to 0. So only what will remain is 1 minus L2. So that is what you are finding. That is delta 1. Delta 1 is for P1. So this is the only thing you have to understand. This is the only thing students find difficult. But it is not difficult because you are already having the equation of delta. In that case, you have to see this forward path. This forward path is touching. There are 3 loops. Which are the loops that is touched by this forward path? Make those loop is equal to 0. Okay, so you are finding that this G1, G2, G3, it is not touching this L2 loop. Okay, that means while finding for delta 1, only the L2 you leave as minus G5H2. Remaining L1 and L3 you make as 0. So that is what is done here. Delta 1 is delta with L1 and L3 as 0. So the actual delta is 1 minus L1 plus L2 plus L3 plus L1 L2. In that case, you make L1 and L3 as 0. So delta 1 you are finding for forward path G1, G2, G3. In that case, only leave L2, make L1, L3 0. So what is delta 1? So whenever we are going to write P1 delta 1, we will write P1, that is G1, G2, G3 multiplied by 1 minus L2. How much is L2? L2 is nothing but minus G5H2. So this 1 minus L2 will become 1 plus G5H2, and that you multiply with the forward path gain G1, G2, G3. So this is a very simple thing. This 4 5 numericals you solve. So far I am solving fourth numerical. I'm going very slow, but all the difficult numerical are also having the base as same. Okay, now you find delta 2. So what is delta 2? Delta 2 is related to P2. What is P2? P2 is G4, G5, G6. Okay, and it is touching L2 as well as it is touching L3. So this P2, G4, G5, G6 is not touching L1. That means is in this delta you substitute L2 and L3 as 0. So what will remain is 1 minus L1, and L2 is 0, L3 is 0, L1, L2 is 0 because L2 is 0. So in this case delta 2 is 1 minus L1. So what this G4, G5, G6 will get multiplied with is 1 minus L1. And what is L1? L1 is G2 minus H1. That means this G4, G5, G6 will get multiplied with 1 plus G2 H1. That's it. Delta 3. Whenever delta 3 I'm talking about, what is delta 3? It is corresponding to P3. So P3 means G1, G8, G6. So whenever G1 is going up, it is touching this loop 1. So this node is common between this path and this loop, and it is coming below. So this node is common between this path, that is path P3, and this loop L2. That means there is not a single loop which is untouched by path P3. That means whatever delta 3 for that thing will be equal to 1. That means you are substituting all the L1, L2, L3 all are equal to 0. So what remains is only the 1 of the formula. Again I will repeat that whenever you are trying to find out what is delta 3. So delta 3 is for path G1, G8 and G6. So G1, G8 and G6. And you are finding that G1 G8 path is touching this loop 1, G8 G6 path is touching this loop 2, and this whole path loop 3 is actually a part of the forward path G8 G6 G1. That means this forward path G1 G8 G6, it is actually touching all the three loops. That means 1 minus all the loop gains have to be made as 0. That means delta 3 you will find as 1. Samely, P4 is nothing but G4, G8, G3. So that is also whenever it is G4, G8, this corner is touching L2 loop. Whenever it is G4, G3, it is touching this L1 loop, and this 8, big 8, which is loop 3. It is actually a part of G4, G7 and G3 only, like this. So P4, I'm writing about P4. So P4 is touching upper loop, P4 is touching lower loop, P4 is a part of the L3 loop. That means all the loops have to be made equal to 0. Okay, so hence delta 4 is equal to 1. Similarly, delta 5. So what is the delta 5 path? So you are going up, then again coming G8, then again minus H2, then again going up and coming below. So this is the P5 path. What is P6 path? G4, G7, minus H1, then again coming back, and this. So again you are finding that this fifth and sixth path, third and fourth path, these four paths are touching all the loops. Hence, as all the this four below, this forward paths are touching all the loops, for them delta is equal to 1. So only the path 1 is G1, G2, G3. It is not touching the loop 2. Hence, whenever you are writing this term at the numerator G1, G2, G3, it has to be multiplied with 1 minus L2. And as L2 is equal to G5, H2, so G1, G2, G3 will be multiplied with 1 plus G5, H2. Same thing, the below path G4, G5, G6, this is not touching this minus H1, G2 loop. Hence G4, G5, G6, whenever you are writing it in numerator, it will be multiplied with a one term which is called as 1 plus H1, G2 likewise. And all the things are now done. We know what is delta 1, we know what is delta 2, delta 3, 4, 5, 6 all are equal to 1. So here we are having all the P, so there will be P1 delta 1 plus P2 delta 2 plus P3 delta T up to P6 delta 6. That means there will come such 6 terms in the numerator and denominator will be comparatively easier. There will be only 5 terms in the denominator. So 1 minus L1 plus L2 plus L3 plus L1 L2. So let us see what is going to be the overall transfer function of the system. So CS by RS. CS by RS is P1 into delta 1. So what is P1? P1 is this G1, G2, G3. So this is G1, G2, G3 multiplied by 1 minus L2. Now what is 1 minus L2? 1 minus L2 is 1 plus G5H2. So this is the first term in the numerator. That is G1, G2, G3 multiplied by 1 plus H2, G5. Second term, that is G4, G5, G6, that is G4, G5, G6 multiplied by 1 minus L1, because this G4, G5, G6 is not touching this L1. So it is 1 minus L1, and L1 is nothing but minus H1, G2. So it is G4, G5, G6 multiplied by 1 plus G2 into H1. This is there. Now other things will come straight away. So this is P3 already found. This is P4 and P5 and P6. So P5 is having minus H2 into it. So that minus H2 is giving minus here. P6 is having minus H1 into it. So hence in the forward path only you are finding there is a negative sign. So that's why these are 6 terms with their multiplicand. So only P1 and P2, they will be multiplied with 1 plus 1 minus L2 and 1 minus L1 respectively. Other things are not multiplied with L1 or L2 anything, because all other four forward paths, that is P3, P4, P5, P6, they are touching all the 3 loops. Hence it will be only P3, P4, P5, P6 at the numerator, because delta 3 up to delta 6 will be equal to 1. And what is the denominator? Denominator is very easy. 1 plus, 1 minus L1 plus L2 plus L3. And I told you that L3 is positive. That means it will create a negative thing in the denominator. So this is 1 plus G2H1 plus G5H2. So this is G5H2 added, this is G2H1 added, and multiplication of these two. Okay, so multiplication of these two is the last term, that is G2H1 G5H2, because this plus is plus of the formula. Okay, multiplied by 2 negative terms. That's why it is getting positive. But this term is that 8. So big 8 you are finding. So this is the very new kind of a thing you are finding here. So this loop, okay, because I told you G7 and G8 are not connected here. So this loop gain is minus H1 G8 minus H2 G7. So if you multiply it, it is G7 G8 H1 H2. So G7 G8 H1 H2, and that will come as negative, because whenever the loop is there in the numerical, it is actually creating a positive feedback. So this is the numerical which is most difficult so far what we have done, because there are 6 forward paths. So forward paths are not problem, but with every forward path we have to calculate how much is the delta, and delta will appear when some forward path is not touching some proper loop. If the forward path is touching all the loops, in that case the delta will be equal to 1. So this is the best numerical to understand what is delta, because somewhere delta is there, somewhere delta is not there, likewise. Now I will give you a more difficult numerical as your homework. It is shown in the next slide, this slide. So you have to submit it almost 23 hours time I'm giving you. So submit by 6 p.m. tomorrow. Instance will be created in Google Meet, sorry, in Google Classroom, as was done previously. So this is also your course activity. 10 marks will be allotted for it, and I'm not going to assess if you are submitting even 1 minute late. So I found last day also some students have submitted 1 minute late. That will not be assessed, because almost 24 hours time I'm giving to you, and almost this numerical is done. Okay, so little bit of variation you have to do, and that will give you the final answer. So what is the main difference between the previous and this numerical? That is this G7 is coming here, and this is a node. Okay, and G8 is coming here, and this is a node. Okay, likewise. So the thing are getting connected here. So in this case, how many forward paths, how many loops, and all those things you can find out. Okay, so this transfer function you find out CS by RS and submit by tomorrow before 6 p.m. That's all. So this is the so we have done 4, this is the 5th example we are doing, and one example was given actually as a homework, and that solution is also uploaded. That means so far we have solved 5 numericals of quite difficult type, and this is the sixth numerical actually which is given here. So tomorrow again we will be having a session, and 2 3 more numericals we will be doing tomorrow as well. So tomorrow is 13th, so that is Thursday, and tomorrow will be our last session on signal flow graph. That's all from my side now. Thank you.